Good morning, everybody. I hope you've all got your coffee in hand and ready for the first session of today. I hope you've been having a great conference so far. There's been a lot of great sessions, and certainly we've been having some great conversations with the guys at the show here online this week. So welcome to this morning's session. What we're going to talk about today is we're talking about innovations in automation, test automation, and we're going to talk about how they really can be used to accelerate and improve performance, quality and reliability associated. And today what we'll be talking about is we'll be really talking about how those initiatives or how those innovations, as I say, can help deliver quality. Now, everybody is obviously we're all virtual today, and this is because of the pandemic, which we're all always talking about. The thing that's really interesting to me about the situation that we're in today is it really has brought forward everybody's digital transformation plans. It's taken plans that previously you were going to say, okay, in the next 3 to 5 years we'll achieve these goals, and said, okay, what can we do in the next 3 months? And that has introduced insane amounts of acceleration and adoption of online technologies like we're using today, adoption of cloud-based deployments of not only our customer experiences, but also our internal infrastructures as well. And we're going to talk about some of those things. We're going to talk about how we first build quality into a DevOps process, and we'll talk about that just as my DevOps pipeline looks and how that has potentially changed within your organizations as you've moved towards more of a remote working cloud-based deployment model. We're then going to talk about innovations in the pipeline that can help us really improve and augment the software testing process. We'll talk about the use of those for low-code platforms. Specifically, I'll use the example of Salesforce today. Many organizations looking at Salesforce and other low-code platforms like OutSystems, Mendix, ServiceNow to see how they can accelerate delivery to the market and do it in a way where they can really kind of push the envelope and take advantage of technologies that are already in place. And then lastly, again, talking about the Salesforce world as an application, but we're going to talk about how we can leverage technology called service virtualization to really eliminate the constraints of your test environment and start promoting remote collaboration. One of the challenges that we have today, and one of our partners in Canada is actually doing this right now, is they're trying to figure out how to create dynamic test environments in the cloud so that they can enable their teams to not be bottlenecked and have kind of more constraints than they had previously because of the remote work and the inability to access physical machines. So let's kind of jump straight in. We'll be doing Q&A as well at the end, but please feel free to throw those into the Q&A box. I am actually monitoring that on the left-hand side as well, so I'll look at that as we go, but please feel free to throw those in and we'll kind of come to those at the end. So first, let's talk about the DevOps pipeline. There really are a couple of different ways that people will talk about DevOps and kind of graphically lay it out. One of these is the infinity spiral, the helix. And this is kind of the one that really I kind of do like to look at, and especially when I'm thinking about quality, because for me, quality needs to be built into this, and it actually needs to be applied at every point of the process. Notice how I'm not saying testing. This is a key thing. So there's a term in the industry, continuous testing, which I do believe is a certain part of the process, is part of the quality activities. But that's a very back-end process still. Even if I'm doing it continuously, if I'm doing it now and then again in the future and just running my tests in a continuous, fully automated manner, testing does not build quality into your application. You really have to build your application with the right foundation. So where does that start? Well, it starts right at the beginning when I'm doing my planning. It starts when I'm defining my user stories. It starts when I'm defining my requirements. Now, we're going to talk about traceability. We're going to talk about how we can integrate our quality data back into the requirements in a few moments. But one of the key things here is where you can leverage techniques like BDD, so behavior-driven development. Now, BDD, though, many people view as an end of pipeline process. You're viewing it as a way of writing your test automation scripts, making it easier to write the scripts. Okay, yes, you can use it like that, but I can also use a hammer to push a screwdriver into a wall. If I really want to make BDD successful, you need to be doing it at the beginning of the process and writing your user stories in Jira in such a way that they can be leveraged later in the process as part of your functional test automation. I'll talk about a little bit more about that as we move forward. The next step in the process is when the first line of code is written. This is where you want to do code analysis techniques. Now, I'm not talking about the basic linting stuff that you would get with Sonar Cube, for example. While that's a good start, and you'll get some initial metrics, what you won't be able to do is you won't get a perceived ongoing value of quality because it's frankly not deep enough. So it gives you kind of some reports, makes everybody feel pretty comfortable. We say, yes, we're doing static analysis. But the reality is, while you get an initial bump in quality to start with, it's not a pervasive ongoing quality. So we'll talk about what I mean about that in a few moments as well. Then as we move forward into the verification stage, this is where we're starting to do our regular testing, unit testing here, typically a developer level activity. However, there are innovations in the market that can help drive unit testing for testers as well, so kind of reduce the technical complexity associated with unit testing. I'll touch upon that in my slide as well, but obviously if you want to learn more about specific technologies, then please feel free to reach out to us as we go through that. This is also where the handoff starts happening between our typical dev role and our typical test role. Test data modeling is a key component here as well, which also you kind of need to start considering different data permutations. Then as we start moving out of our verification phase and start doing more integration and system testing, now I'm trying to test the non-functional requirements of my component. I'm trying to verify how it integrates with other external dependencies. This is where service virtualization can come in and help. And then also is where I'm starting to have to kind of increase complexity of test environment management. Now, there is an additional step though. So we go now and we go verify, we package, we release, we configure it, we get it out the door. What happens in production? This is where the monitor phase really can be very, very valuable to provide feedback of the quality of the application as it comes out into the real world. Again, here, we are not doing quality though. We are doing testing. So I really want to be very clear here, and this is why this is actually a different design. It has like a little dotted line around it. I want you to be very, very careful. When people talk about shift right testing and testing in production, you have to bear in mind that this can be dangerous. You are not going to build quality into your application if you're only reliant on that shift right. You have to have the basics in place. You have to have, doing the best efforts you can to make sure that what goes out into production is of high quality. This shift right is to detect the anomalies. It's to detect the things that you didn't think of. If you are just developing, releasing, you have to seriously consider if a rollback is a problem. Now, it is a problem, or should I say it isn't a problem, if I'm rolling back some functionality, which is, I don't know, it's just a pure customer experience thing. Let's say it's some new functionality that we're prototyping. Let's say it doesn't touch any of my business critical functions. But if I'm in a regulated space, or if that functionality is tied to personal information, credit card information, if it has any level of real security risk, and I have to roll that back, in many regulated industries, I have to report that. I have to say, I did a rollback in production for these reasons. And if you have too many of those, your business is going to be fined. Now, that doesn't happen in all industries. It doesn't happen to all applications. You can categorize your applications and your modules to kind of help mitigate that. But I want you to be really, really conscious when people talk about shift right, canary testing, blue, green, that you have to take that in mind, as that's to capture my exceptions. It's to prototype new functionality and get that feedback rapidly, which I think is great. But be very careful that it doesn't become an over-reliance on, hey, we don't have to test. Let's just test it in production, okay? Okay, so let's talk about how we can actually deploy that and make that successful. I'm a big fan of the testing pyramid. I think this is a great way of organizing your testing structure. So again, testing right now I'm talking about. This is where we say we have a solid foundation of unit tests, which give you broad coverage. They're easier to diagnose. They're much quicker to run. You're going to get much more rapid feedback closer to where the developers write the code. As I said, there are innovations that can help with pair development here as well, where the developers are writing the code and the SDETs or the test engineers are actually writing the unit tests as well. Moving further up the pyramid, we start talking about API testing, which really is the sweet spot when it comes to the testing pyramid in my mind, because it helps me blend the functional behavior of a integrated or semi-integrated capabilities with the underlying code constructs and the code level testing the unit testing provides. Then at the top is our end-to-end UI-driven tests. We want to actually minimize those. We want to focus them. We don't want to try and test the entire application that way, because really those tests, as I said, they're end-to-end, which means that it's a complex test environment. But also, we all know that UI testing is brittle. And again, I'll talk about some things that are available in the market that can help us with that. I did say this was testing, though, and there is a missing layer of this testing pyramid, which is what helps us building quality into the code base, which is that deep code and reliability testing that we mentioned earlier, going beyond kind of basic linting functionality. But many of you are probably saying, yeah, that's great, but that's not us. We're still heavily manually doing a lot of manual testing, and that's the case. So you know, the situation that you're probably in today is you probably say, I've got an inverted testing pyramid. We're going to talk today about how you can take that, and actually many people call it the ice cream cone, and how we can melt it, how we can go from a purely manual centric model into leveraging some of these other techniques. Okay. The reason why we're in this situation is the quicker to define from the UI. UIs are typically where your business requirements are written, so you will understand the UI level. Decomposing that down to the other levels is difficult. And actually, it's really difficult when you start talking about API testing. And we'll talk about how we can address some of that. My colleague, Chris Colosimo, gave a presentation yesterday about codeless API testing, and he talked a little bit about that too. So I'll probably touch upon some of those similar things. I see a great question in there. Chat already, thank you very much. And I will try and touch on some of those topics as we go today, and then I will actually come back to that and make sure I touched upon everything. So, but thank you very much for that question. It's a great one. Okay, so, and I think actually this may be where I start touching upon it a little bit. The question is, okay, so this is great in theory. How do I now actually integrate that into my pipeline? And what does my pipeline look like? I did mention this earlier, saying it starts with the requirements. I will kind of come back to Jira specifically in a few moments. And actually, if I remember, I'll talk about Jira and test management as well, kind of give you some pointers there too. In fact, actually, I'll do that now. So Jira is ubiquitous. Probably everybody on this session today is using Jira as your agile planning system. Jira doesn't actually, it has a couple of challenges. One is scaling across multiple projects into kind of what's termed a value stream today. There are components within Jira, such as Jira Align, that can help with that. There are the other limitation of Jira is there's no native test management functionality built into Jira itself. So it kind of is a massive hole from my perspective from the point of view of their solution, but they have a marketplace. In that marketplace, there's some great components, some great modules that plug into that. We at Parasoft use X-Ray. There are kind of the top three are Zephyr, Qtest, and X-Ray. We use X-Ray because our team did a full end-to-end evaluation and identified that that was the best one for our needs. I'd advise you to kind of look at those three. The reason why I really like X-Ray is that it's integrated into Jira rather than being an external system where you've got to plug into Jira that talks to that external system. So I kind of a big fan of that. And there are concerns about, okay, well, is it scalable, blah, blah, blah. It is. You just have to make sure you configure it right. Okay. We'll come back to that at the end of the pipeline, though. So it starts with writing my user story in Jira, and this is kind of where BDD steps in to start with as well. But the first thing you do is you define your story. Typically, depending on how you're structured, the team might do that independently. You might be involved in that, but you should be thinking about what the acceptance test is going to look like. How am I going to test this story? The reason why I've tagged this as dotted line around it is that not every story is going to have an acceptance test. This is just the reality. You really should do. Every story should have some way of acceptance test, but you might find the story is too granular and is actually covered by something at a higher level. Now, needless to say, what you have to make is, once you've made that determination, is you then have to make the determination of how am I going to test it. Go with automated first. Not everything will be automated, but apply your 90-10, 80-20 rule. If you're doing things end-to-end manual and you've got a lot of them, you're not going to keep up with the DevOps pipeline. You need to start automating some things. Starting at unit testing level, then going through the API, and then going through a web UI at the top. Typically, I see most people using Selenium for web UI testing. There are other frameworks, Cypress, for example, but Selenium certainly has the bigger market from the point of view of everybody using it. And this top layer is actually where your BDD can help. Cucumber being the Java-based framework, SpecFlow for .NET-based development is a little bit more popular, but it doesn't mean that for .NET development you have to do SpecFlow and vice versa. But Cucumber typically sits at these higher level of the pyramid. Now, one of the things I want to highlight here is you'll know that I've got this little kind of steering wheel from an old ship across the top for those that don't recognize it. That's the Kubernetes logo. Kubernetes is a technology used to orchestrate containers and orchestrate those within a DevOps pipeline is a really, really valuable way of really building dynamic development and test environments. I'm not going to go into containers and Kubernetes today. If that's of interest to you guys, we have actually a white paper that talks about these as well on our website, and just send us an email afterwards, and I'll forward that on to you guys as well. Now, the interesting thing about these functional tests that are towards the top of the pyramid is you can also re-leverage them for doing your non-functional requirements. So load performance testing or penetration testing from a security perspective. This is a great way of shifting left, to overuse that term, those non-functional techniques that or exercises that are normally done at the end of the life cycle. What we want to do is shift left as much as possible, do things as early as possible in the pipeline so we can get the feedback. And we want to do them not just left, but continuous. So we'll talk about this when we get to talking about service virtualization, and we'll touch upon that a couple of times. But service virtualization is a key enabler to allow you to be able to do these techniques earlier in the process. Now, security, though, I did mention security there from a penetration testing perspective. That is still a testing activity rather than what I view as building quality in. You're testing quality. You're doing your quality assurance. You're not building the quality in. That's the piece that really deep code analysis can help with it from the beginning. Now, as I said, this is really a very powerful way of identifying problems at the earliest stage within the software development process. Things which are actually very difficult to uncover later when you're doing manual testing, because you're not running through all of the different corner cases. You're not using extremes of payload or every data permutation. You're probably constrained by the data that you have access to in your systems. So you're not going to be able to uncover a lot of these underlying issues in a manual testing or even an automated functional testing practice. These kind of issues, they get uncovered in production. So really what you want to do is you want to try and find these at the earliest stage, and that's where leveraging industry standards and industry best practices can help. So there's a lot of those for the security world. So if we're talking about an application, an enterprise application in maybe financial services, healthcare, or what have you, you're going to probably be looking at OWASP, which gives you top 10 vulnerabilities to look out for in an application. Or you might be talking about CWE, which actually covers a lot more. There's about, I think it's like 400 CWEs in total. But the thing about CWEs is that that's too many. So many people will focus on the top 25. And then there's actually an additional 15, which will be on the cusp, which I highly recommend people look at, which makes it 40. What we have at Parasoft is we have technology that'll do all of the top 10 as well as those top 40, so that you can actually get a real-time continuous view on security of the underlying code base, but also it reduces the burden from the point of view of an audited process at the end of the pipeline. Now, security is one part. reliability is another. And actually, one industry area where reliability is critical is in the safety critical industries. So this is automotive, medical devices, it's aerospace, and the standards that are leveraged there, MISRA, which originally came from the automotive industry, but now is accepted as the cross-industry reliability standard, and then AutoZAR, which is actually the kind of the modern version of that. Actually, don't want to get into the details, but it will be called MISRA again in about a year or so's time. Okay, so there are standards out there that's typically used for C and C++ development. However, there are best practices as well within the Java world around reliability and effective. So there's actually a number of those standards effectively in our same technology from a code analysis perspective. Now, the whole goal of this, though, as I said, is to do quality and build quality in, because prevention is a lot less expensive and a lot easier to do than detection. Now, we have detection from the point of view of static analysis as well, or code analysis. There's a technique called flow analysis that'll go deep within the code base, and that can help with the detection. But really, preventative approach is the one that you want to focus on, or you want the team's focused on here. This is to find the catalysts. This graph here on the right-hand side has been kind of taken and drawn by a number of different people over the years. Originally, it was done by Caper Jones in 1996, based on their research, and they redid their research in 2017 to say, are we doing, has it got better? Actually, we're doing it's exactly the same. It's just now with Agile, we're doing this a lot more. And basically what we're saying is most of the defects are introduced at the beginning of the process, but most of them are found right before release, where it's a lot more expensive. And there are still ones found in once we've gone to release. What we want to do from a quality perspective is we want to shift left the detection of those defects, but also what we want to do with the application of code analysis is actually reduce the number that are introduced in the first place. You're not going to eliminate them all. You're not going to eliminate everything from being found when you get to release. But my point is you want to reduce that so the number of rollbacks you have to do because of shift right is reduced. If your number of rollbacks are increasing and your argument is, well, we're doing more releases to production, that means you don't have a quality process. Okay, so moving up the pyramid, let's talk about unit testing. And actually, this has been traditionally a developer-centric practice, but times are changing. As teams are collaborating more and more, testers are being asked to start working with this. And we actually introduced some technology in our JTest product that is called the Unit Test Assistant. It's to help reduce the technical complexity associated with unit testing. What we're talking about here is the point of unit testing is to really not just build a regression suite. It can be done to do that, and that's one of the valuable components. But it's ultimately you want to have better designed code in the first place, and it's all about how making sure that my code is structured properly for testability. Now, you want to leverage open source frameworks. JUnit is a great example there. Mockito is an example of a mocking framework. And by leveraging open source frameworks, you don't become locked into a proprietary technology ultimately. And we'll talk about Selenium from that perspective too. I talked about this. This is, unit testing is easier to diagnose. It's quicker to run. A couple of things you want to be careful of when you talk about unit testing and actually testing as a whole. People focus on code coverage as a metric, and that's great. It is a metric. What you want to do, though, is tie all of your testing back to the requirements, so you understand that your actual business requirements are being tested as well. So code coverage along with test coverage are both very valuable metrics to use kind of in tandem with each other. Okay, moving up the pyramid to talk about the functional testing aspects and non-functional as well. This is where API testing comes in, but let's start from the top. Let's talk about UI testing efforts. Here, again, open source. You want to be leveraging the Selenium framework. Now, there are other frameworks out there. As I said, I mentioned Cypress before. That's actually increasing in popularity, especially within those that are doing JavaScript. However, there are limitations with it associated with how it runs within the browser. And also, JavaScript has also a number of, let's say, limitations. It's very, very powerful. You can get going very quickly, but you can very quickly get in a mess if you don't have the right structure in place. I'm actually a big fan of using Selenium and specifically using Java. The reason being there is you can actually put really a foundation in place that really helps to make sure that you're doing things the right way. And one of those techniques is called the page object model. This is a technique, Angie Jones, she actually is a big advocate of this practice, as well as a lot of the other influencers and thought leaders in the industry. It's a way of building reusable objects that in essence get changed together into a test script. Now, if you are a test engineer and you say, well, but I'm not a coder, don't worry, you're not trying to write an end-to-end Java application. What you're doing is you're writing a test script. It's just in a different scripting language. And there are tools and technologies that can reduce the burden of that and make life easier. So for example, Selenium IDE is a plugin for Chrome that allow you to start creating objects, and then you can spit out Selenium scripts. Challenge with that is it doesn't use the page object model. At Parasoft, we do have our Parasoft Selenic product that has a recorder as well, and it'll create you your pure Selenium or Java-based Selenium tests, leveraging the page object model. But when we get to looking at UI testing, one of the challenges is the maintainability of those scripts, and I'll talk about that when we actually get into looking at the Salesforce example. API testing, critical layer in the pyramid, it's the sweet spot. Really, you can leverage this to really enable shift left performance and shift left penetration testing. We'll talk about how we can reduce the complexities of that in a moment. As I said, if you didn't catch Chris's session yesterday, I'd advise you kind of go back and watch the recording. He talks about how you can make API testing really easy to adopt in your organization in a purely codeless way as well. Because API testing, you don't have the UI to look at, you have to start looking at kind of the underlying code pieces. And then service virtualization is a technology which helps us eliminate the constraints in my environment. Because when you're testing something, you're no longer testing just one application, you're testing a bunch of connected pieces, and you don't have control of all of those connected pieces. Again, we'll talk about this when I get into Salesforce in just a couple of moments. Now, all of this is going to generate a lot of data. You don't have to do all of this day one. You can take bites of the puzzle, or bites of the elephant. You don't bite a puzzle, but you can take pieces of the puzzle and plug them together. But what you want to do is make sure that you're putting these together into a central place from a reporting perspective. Otherwise, as you start doing these practices, you'll have a whole bunch of disparate reports that you're trying to figure out what the state of the application is by looking across half a dozen products, looking against half a dozen static HTML reports. What this also gives you the ability to do, if you're aggregating into a central location, is very easily cross-correlate that data with your work items. So for example, you should be able to control the status of your work items. So this, within the test management world, in X-Ray, for example, is setting the status of a particular test within your Jira system, so that when you're going through Jira, which is where the development team are spending most of their time, they can quickly see what things have been tested via the automation scripts and quickly see about the state of the quality from that perspective. Now, you do also want a quality view where you're actually aggregating not just the test status, but also code, the code analysis stuff as well, potentially even looking at code coverage and aggregating all of that into one central report. So these two things together become bi-directional traceability. And then one of the things that we do at Parasoft as well through our reporting analytics dashboard is we have the ability to, as you're manually triaging the test results, you can say, this is a problem, and you can create a defect or issue back in Jira. So this is how you plug everything into the pipeline. I'm just scanning as I see a couple of other questions just appear. So, okay, I will come back to those. Great questions. Thank you very much. I really appreciate those, and they're spot on. So I will come to those. I'll kind of do the Salesforce stuff quickly, and then we'll kind of give ourselves 15 minutes for questions at the end. Okay, so let's move on to our second story. So we talked about the pipeline, we talked about what we need to do. Let's talk about how we can make some of this easier, okay? How can we leverage innovation, specifically concepts of AI and machine learning, which you're gonna hear, oh, everybody has AI, everybody has machine learning, and yeah, let's kind of take this all through a lens, right? What you want to do is let's just get rid of AI and machine learning from the conversation. Let's just say, what can a technology use to assist me in this process? Now, let's talk about this specifically when it comes to Salesforce. So Salesforce you might be familiar with as a CRM or a customer relationship management system. It's a system that many teams will use within their sales team, but actually also within their support organization to manage those interactions with customers. What you may or may not be aware of is it's actually becoming what's referred to as a low-code platform. I shouldn't say becoming, it is. It is one of the top 5 low-code platforms. I would argue it's either number 1 or number 2, depending on who you're looking at from an analyst report perspective. It competes with things like Microsoft Power Apps, OutSystems, Mendix. ServiceNow is also getting into the space as well. What it means is I'm building on top of a platform that helps me accelerate my delivery to market because it has a whole bunch of reusable modules within the technology that help me get up and going. But it's really quick and easy to get up and growing, but it gets more complicated very easily. So, you're going to start, you're going to have like a little project leveraging the Salesforce Lightning platform, used to be called Force.com. And that project will be successful. So they'll say, okay, it's a good prototype. Let's make it a little bit more. Let's put some custom code in here, which Apex is the language that people use to do that. So you're going to couple of little custom modules. Let's also connect it to one of our enterprise systems as well, because we want to pull data from, let's say, the mainframe or some other external system. I want to pull that data into the interface as well. And then that team's going to be really successful. And then it's going to be like, hey, this other group could also start using that. And actually, the data that they're generating, we want to consume that in a different system. So we want to use Salesforce as a backend. And then it's going to increase in adoption. And we're going to say, you know what, that's great. Let's build more and more and more. And then you're going to say, well, that's great. We're having great success using Salesforce for my customer-facing stuff. Let's actually also use it just to store all of the data, and let's bring that into a different system. Now, the challenges here are that now you've become very reliant on a platform, which is great. It's managed by a different team. You're going to be able to accelerate much more from a delivery perspective. But there are some challenges when you start thinking about how do I test all of these different applications? And I can break those challenges really into 5. And we're going to touch upon each of these briefly later. And this is not just with Salesforce. This actually is across all of these kind of low-code platforms as well. Salesforce is my example today. The first is automated UI testing is unstable and complex. You don't have control of the DOM model. It's being generated by a different system. So anybody that's done any UI-centric automation will understand that you spend a lot of time playing whack-a-mole, whether or not you're building on top of a Salesforce. It's a little exasperated with a low-code system because that back-end system could go through changes that you're not aware of. Typically, I mean, if actually Salesforce does 3 releases a year, you do get a lot of forewarning when that's going to happen. You get early access to sandboxes, etc. So usually when it goes live, you should be okay. Different systems have different rules. ServiceNow, you can actually say, well, I don't want to take this release, but you will have to take the next. So you always have to be one back. Mendix, you can actually do on-premise. So you can control it a little more, but they will stop supporting you. I think it's 12 months after the release. So either way, your testing has to be stable. So UI testing is great, but it's at the tippy part of the pyramid. We need to think about how we can do API testing that uncovers the next problem. Those APIs are out of your control. It gives me a great targeted way of testing the application, but how can I go after those if I'm not the one creating those APIs? The environment as a whole is complex now. Right? It's not all just the platform. The platform is pulling data from a different system, but also the other system is using data from that platform. So we have to think about how I can get better access to the system. We also have to think about how the teams collaborate. Salesforce runs what's referred to as their org. So actually every application is deployed inside of the same system. So you can run into collisions. You need to make sure that you've got a lot of collaboration from the point of understanding where the quality is of each other, but then you also need to be able to separate out so that I can test and you can test independently without stepping on each other's toes. As my deployment gets more complicated, obviously I get more challenging situations, and I also have to do performance testing of this system. Just because it's a low-code platform that's managed by Salesforce in the cloud doesn't mean to say you don't do performance testing. For a very simple reason, those customizations you've been adding with the Apex code, that isn't Salesforce's code. The way that you're using the flows, that's not their code, that's yours. So you need to validate that your code is actually meeting those performance requirements. Bottom line is, as you start increasing the business criticality of your adoption of a low-code platform, you have to be very, very cognizant that you don't end up with an untestable hairball. And really, this is because the forgiveness for failure reduces as your business criticality increases. So in those early stages, you're throwing something out, you're getting prototyping going, everybody's happy. But as soon as you start building more and more business critical functionality, a project that's essential for your organization to be successful, and that fails, you're going to run into a major issue in the business. And this is where you guys can help by putting a quality assurance process in place and making sure that we're validating the use cases in a fully automated manner. Now, as I mentioned, I plugged Chris's session from yesterday 2 times already. This is the 3rd and final time that I plug Chris's session. This is where we can start to leverage AI and machine learning by making aware the technologies that we use, making them aware of the low-code platform that we're leveraging. Now, the technology here fully works with a non-low-code system as well. It's the same kind of process, but what we're talking about is building in AI that can streamline that and make that valuable. So first of all, through the use of a Chrome plugin, for example, recording my interactions with the website and recording those interactions and creating test scripts that are pure Java, leveraging the page object model. This is what we do with our Parasoft Selenic product. If you have a purely manual-centric web testing of a web project today, this is the first step. Create some of your workflows and create Selenium scripts so you can start to automate the front end and the UI. The key thing for me here is you want to be leveraging an open source framework. Don't lock yourself into a vendor platform, because while you'll say, look, this is going to be easy, codeless, I could just put the pieces together, at the end of the day, somebody needs to write code. And if you're writing code within a proprietary platform, you're locked to that vendor. There will be ways of saying, oh, you can export out, or when you export out, you will lose the page object model. You will lose all of that hard work. So work with an open source platform to start with, do it in pure code. As I said, I'm a big fan of Java. I think it's a great way of kind of putting structure around the development process. And if you have the right tools, it doesn't actually become a very large and steep learning curve. Now, what you also want to do, though, is by leveraging that page object model, you're actually making the tests a lot more reliable and maintainable. So meaning that if a change happens, I only change it in one place and the test scripts all inherited it. But you're not always going to capture that up front. So what you want to be able to do is to leverage runtime analysis of the execution of the scripts so that you can identify what changes need to be made as part of the automated or continuous testing process. This is where an integration with Jenkins comes in. By plugging in our AI engine into your CI process, and this will plug right into your existing Selenium scripts as well. We're able to identify when a breakage occurs and then self-heal that, not changing the script though, because what you want to do is you want to give the tool to give you recommendations, so you can then review and say, okay, what's the right change? What should I make? And those findings can help you then tweak the process and tweak the test script so it's more maintainable moving forward, or it's more reliable moving forward. Now, the next piece is, okay, how can I actually go a little further there? Remember those APIs. API testing are more resilient, it's easier to run, quicker feedback. I can run through a whole lot more data permutations, which I'll re-emphasize in a moment. How can I get there? This is, again, where AI and machine learning can help. Parasoft SOA Test, which is our API testing product that Chris talked about. Darn it, I plugged him 4 times now. All right, that really is the last time that I plugged Chris. That really makes API testing much, much easier to adopt. It streamlines the process. It analyzes the traffic that has occurred between the UI or between your automated Selenium scripts, and then stitches that traffic together into a test scenario. It's much more than just a record and playback. The same way that the recording in Chrome is more than a record and playback because it's giving you that starting point. This is actually going to stitch together those API tests into an API scenario that you can plug into your CI pipeline, and then you can teach it. You can say, you know what? I normally want to do an assertion when I see this type of payload, or when I'm doing this type of authentication, I pass the token from here to here, and then that training makes the brain much smarter as you go. So what we're doing is we're trying to address three key challenges when you're testing or building in these low-code platforms. First of all is confidence, and this is where you can leverage Selenium to validate the UI, leveraging AI and machine learning innovations to simplify creation and eliminate maintenance issues. But also you can start getting early stage visibility into the performance of your application. By benchmarking your UI tests means that you're able to identify particular user experiences that potentially are going to be falling outside of your SLA. The second piece is speed. And this is where API testing sweet spot is in this kind of scenario. API testing is just frankly quicker to run. You don't have to do the complex end-to-end scenario. You can target it. You can also say that I don't have to start up a browser because I'm doing it in a purely headless mode. This can reduce your execution time significantly. So actually, this is actually the number of 97% is from a specific customer use case. So there, they had a particular flow, would only take about 10, 15 seconds to run, but that was only one run through. And they had to run multiple data permutations to be able to fully test and get complete test coverage for that particular flow. Leveraging API testing, we can rationalize that, parameterize it with test data that's generated from a test data generation engine, and then run all of those scenarios in 97% of the time that it would have taken to run them truly end-to-end from a UI perspective. Also, this is a great way of targeting your performance testing. Even in a non-low code environment, you can actually do performance testing at the API level much more effectively than you can by doing purely UI-driven tests. You will want to bring both of these together. You want to do kind of this hybrid where you leverage API testing to kind of test the back-end infrastructure and put the back-end infrastructure under load. And then you'll re-leverage your Selenium tests to validate the user experience when the system is under load as well. In Salesforce specifically, this is how you can target your particular pieces of customized Apex code and performance test those. So that's how we got our functional testing running, but there's a problem, the problem of agility and the problem of the test environment itself. And this is, I say, ubiquitous across all systems. And this takes us to our third and final topic for today's webinar. And that's how we can enable the testing environment. And within today's world where we're all kind of remote now, there's no physical access to testing infrastructure anymore. How can we further enable remote collaboration within those environments, leveraging synthetic test data and the dynamic test environments with service virtualization? So let's take ourselves back to the Salesforce example for a second. So you remember that we got these connected and interconnected systems. There are really two use cases here. The first is when I'm not talking about the back end, is where I'm talking about just systems where I'm using Salesforce as a front end. So I'm not using Salesforce as a back end, I'm using Salesforce as a front end, but I want to pull data from other external systems. In this world, those external systems may not be available. Let's say you're doing the remote access, you might actually find, oh, there we go. You might actually find that you're challenged because you don't have access to that system because it's behind a VPN and your test infrastructure is not ready yet. It's all in maybe it's a public or a hybrid cloud environment, but getting actually access to a system is just not possible right now. Maybe it's not going to be possible ever. And maybe you're talking about a mainframe system where you don't have a scheduled access. You have a scheduling conflict. I get that system between midnight and 4 a.m. And if I'm not ready, I am going to lose that time window. Maybe I also can't control the data permutation. So even if I have full control of a system, let's say it's a Dockerized dependency that I can spin up in AWS and everything's great, but I need to give negative bank balances. And that's not something that the system supports without me going through some other complicated workflow. These types of situations are exactly the things that service virtualization can help with. So when you're testing an application that's dependent on an external system, you can test it without those constraints. Now, if I now move to the other use case, where I'm using Salesforce as a backend, this is where that Salesforce infrastructure might not be available because others are in there working on it. Now I'm actually roadblocked. And actually, specifically in Salesforce, the first kind of roadblock you have to be aware of are API limits. The Salesforce's business model is all about charging for the number of API transactions. And certainly when you're doing performance testing of an external system, especially continuous performance testing, which is really something I'm a big proponent of, you can very quickly hit your API limits. Service virtualization allows me to simulate the Salesforce environment so that I am not consuming API hits from Salesforce. I can do my shift left performance testing in my own sandbox without having to potentially have a data collision with the different teams within the same org. I don't have to worry about trying to stand up dynamic sandboxes inside of Salesforce, which you can do, but now I'm building additional complexity into my DevOps pipeline, and maybe I'm not ready for that. So service virtualization becomes a very, very powerful enabler to drive agility and collaboration. So simulating both my dependent system that I'm pulling data from and bringing it into my low-code platform, as well as simulating the low-code platform and potentially APIs that I'm using to bring into that others. We leverage AI and machine learning to actually figure out what those simulations look like by monitoring the behavior in a similar way that we monitor the behavior of a UI interacting with backend services. We can actually analyze the traffic and build a simulation of how it should behave through a variety of different techniques. And this is, as I said before, it's actually really a very powerful technique for shift left performance testing, especially in Salesforce because of those API limits, but across industries and across applications. So let's wrap up. Oh, actually, one last thing. Okay, so as I mentioned, especially in Salesforce, you've got multiple teams working in the same org structure. You have to make sure that you collaborate correctly and you have complete visibility as to what's happening across the teams. This is where that centralized reporting analytics dashboard comes in again. You can actually start to bring in data across all the different teams into a centralized dashboard, get a view as to whether a team's ready or not, so that you can somewhat synchronize your pushes into the production environment. Okay, so let's wrap up by talking about a particular client that has actually leveraged these techniques in the travel and hospitality industry. And specifically, it's all around how they're able to really get from that fully manual process into an automated process. Now, the way that the ROI was discussed here within their management team was all around how they can really support the Agile and DevOps initiative. Because the cost of doing testing from an Agile and DevOps perspective was accelerating significantly. The teams were having to get bigger. It was slower. So by doing test automation, we were able to kind of start addressing that. So I'm going to touch upon this quickly, and then so we have time to get the questions. So I'm going to be very quick here. So their existing UI testing practice wasn't scaling for Agile. And more importantly, the existing UI testing or automated testing solution wasn't actually working very well for Salesforce. It was constantly running into brittle element locators, UIs changing dynamic elements, and it was taking a lot of time to maintain that specific environment. They were very, very nervous about adopting Selenium. The team were not comfortable with writing the code. They were also not comfortable with the maintenance because they'd seen the maintenance problems in this other system. By leveraging Parasoft Selenic, we were actually able to reduce the burden over actually how do you create the test in the first place. It creates like 90% of the test fully automated out of the box. And in fact, the most complex use case there actually ran straight out of the box. Now, the challenge of maintenance goes away because of that runtime analysis associated with the CI/CD pipeline. So it was able to really get the full process, get up and running on Selenium very quickly. Then we move forward to saying, okay, how can we actually run through all of our scenarios very quickly, run through all the data permutations? How can we mitigate and avoid the amount of test refactoring that a UI change introduces? So actually a UI change for that particular team, they would lose an entire sprint's worth of testing because it would take them 2 weeks to fix their test automation at the UI level with a combination of Selenic and then API testing from Parasoft SOA Test. They were able to reduce that significantly, not just from the maintenance time, but also the full test execution. So full test execution took less than an hour versus actually several days in the previous scenario. And then last but not least, and actually this is the area where we actually started with this team, was around agility and data inconsistencies within their test environment. So the test environment having a big shared test environment meant that the data was getting corrupted. People were shredding on people's toes. They were having to coordinate releases, coordinate data resyncs in a very, very careful way. By leveraging service virtualization, we're able to unblock that process and get more reliable feedback as part of the CI/CD pipeline. Okay, so we'll switch to questions. But before I do that, just a little plug. We have an upcoming automated software testing quality summit. This is actually just one day. It's not even a full day. It's actually, how many hours is that? It's like 2.5 hours. These are going to be sessions with customers. It's going to be kicked off by a keynote from Forrester, Diego de la Luce from Forrester, the analyst that covers functional test automation. And then we're going to have a number of customer case studies. So 20-minute lightning sessions. They'll talk about their problems, their challenges. It'll cover unit testing, it'll cover API testing, and it'll cover service virtualization as well. So I definitely invite you to come join us for this, hear from your peers. It is a peer-centric conference. It is not a vendor plugging session. So you should be able to get some good kind of hints and tips about challenges that others have faced in adoption of this. Okay, we have 10 minutes. I got some great questions. Let me kind of step through these as quickly as possible here. Start at the start, which would be awesome. However, I'm on an older program, and it's very difficult to be baking tests in while we are transitioning into a pipeline, as they are not there to start with. Oh yeah, this is a very common situation. I think I saw another one that was similar to that later. Any advice on how to manage both creating new tests to go, as well to go with the automatic processes? Let's not say automatic, let's say automated. I'm not a fan of automatic testing. Automatic testing is kind of like it's a shotgun at a target. Yeah, you're going to hit some things, but you're going to miss an awful lot. I much prefer the terms automated or assistive, because we're not removing the tester from the process. This is human in the loop workflows. AKA integrating with Jenkins or the like and moving manual into automated ones at the same time. Okay, great. So how do I go from a fully manual centric process to this DevOps pipeline that we were talking about earlier? You know what? You're not alone. In fact, actually, I think the next question is very similar to this. What I would say is you need a foundation in to start with. You need something. Okay, so if I go and slip all the way back, let's see if I can get to my pipeline slide. Let's go ahead and just look on this one. I think this one's a good enough one to focus on. Let's see if I can actually progress it a little. Okay, so what you want to do is the pipeline needs to be in place to start with. Okay, you can create your automation scripts and run them externally. There is value to that, but what I will say is if you're not building them with the view of them running in a pipeline in the end case, what you'll end up is with a bunch of automated scripts that you have to run manually. If you take the view that this test has to be a fully automated test and has to run continuously, therefore has to plug into the pipeline and run without me touching it again, that's how you can move forward. So don't build an automated test off to one side. You can do this, but I'm telling you not to. What you want to do is you want to build an automated test and then integrate it into the pipeline as quickly as possible. Now, you have to take a look at an inventory of where you are as an organization. If you are a purely manual-centric testing organization today, my advice would be try melting the ice cream cone, go top down. Don't, though, spend all your time trying to automate every use case at the UI level. That is a big mistake. What you'll end up with is a ice cream cone with a cherry on the top. You'll end up with a little bit of manual testing, a whole bunch of functional UI testing, and then nothing else. I actually call it the martini glass, because what you'll find is you'll completely skip the API testing and the development team will do some kind of UI testing, okay? So what you want to do is you want to look at trying to get a step forward. So look at your use cases, create something to start with. Don't necessarily start with the more complex. You might try it and see if, hey, can I build like a good end-to-end functional test scenario and just have something as a smoke test. But don't worry if that most complex scenario you can't automate. just try a few. Get something in place to automate at the top level, but do it the smart way. Don't start building in automation with a tool that you look at and you go, this is good for now, but in 2 years it might not work for me, but you know what, I'll worry when I get there. Because as soon as you start building in your test automation and your fully automated processes, that technology is going to be sticky. And if it doesn't meet your ultimate end goal, if it doesn't meet the world of, okay, I know that, let's take API testing, for example. I know that ultimately I'm going to have to do some API testing against an EMB that's an MQ transaction. And the technology that you're going to leverage doesn't support that today. You're going to have 2 tools in your pipeline, or you're going to have to migrate. So don't do that. So what I'm saying is take a bite out of each layer. Take a bite out of functional testing and then say, okay, I've got something, it's better than nothing. Now let me start looking at what I can do from an API testing. Don't try and melt each layer individually, kind of try and grow it out, if you know what I mean. So hopefully that was good, or should I say useful. Okay, so we are currently about 70% of UI testing and 30 of non-UI. Okay, well, you're moving in the right direction. Trying to switch to the other way around, good. Big challenge is how to identify what requirements software challenges should be tested by UI versus non-UI. Have not really found any good guides for that. You know what? That is a challenge. And you know what? This is where you really need to pair and partner with your dev counterparts. And you need to be asking yourself, do I have to test this from the UI perspective? And that is not, can I? Do I have to? And the times when you have to are when there is end user, I'm sorry, my brain's just gone for a second. This is what happens when you start a presentation at 5:45 West Coast time. When it has characteristics which are very much reliant on the end user experience. Those characteristics are ones that are browser specific or browser dependent. If you're talking about non-functional characteristics, which are the speed of the flow, data permutations, all of that, do it on the API. If you're talking about something which is like, well, I've got a lot of JavaScript that's running in this, that JavaScript is running in the browser, and I need to test the JavaScript, then that needs to be a UI level test. Now, don't worry about running every data permutation though. Let's say I have a particular use case that, yes, it has JavaScript, so I have to be able to test that, but I have to run through 20 different data permutations. Let's run 1 or 2, so positive, negative, UI-centric tests through test automation with Selenium, and then let's do the rest of them. In fact, actually, I would go beyond the 20, right, and actually do those at the API level. So do a mixture of the 2. Then use that correlation of the requirements so that you understand your full test coverage within Jira. Hopefully that was useful. And again, there's actually, I'm going to switch back to the last slide because there's actually an email there at the bottom. That's actually not my email address. My email address is mlambert@parasoft.com. I have a colleague in the general chat channel. So Joy, if you could just send that my email address as well. So if somebody wants to kind of contact me directly, they can do. But I will say that info@parasoft.com, you will guarantee to get a response. With me, sometimes I get a little overwhelmed. But if you would like to follow up on any of those, please feel free. Okay, next question. I see more questions coming in. Great questions. Hopefully we can get them and try and follow up afterwards as well. You talk about testers starting to work at unit testing, but who is primarily the person that writes API tests and creates the second question? Is it, can we reuse code in API testing and apply it to UI testing? Okay, so great question. API testing often falls into this no man's land. Developers go, hey, you know what? I built the API. There's documentation. There's Swagger over here. You guys can do everything from here. And then you look at it and go, I have no idea what this thing does. And, okay, I'm going to click a few things, do a little bit of Swagger Hub integration with SOAP UI, and then I'm done. I'm out. So API testing is a shared responsibility. Development needs to deliver you not just an API, but some tests that you can reuse so that you can further expand upon them. Parasoft SOA test is actually designed for this purpose exactly. So you can the developers can create those initial API tests. You can then take them and very quickly chain them together into a scenario. You can then leverage the AI and machine learning to stitch everything together and create those API tests very, very quickly. Now, That's the last. This is the last time that I plug Chris's session. He talks about exactly that in his session. Okay. Now your question is, can I go bottom up? Not easily. I'm sorry. There's really not much that you can do, in my opinion, from the point of view of using APIs to use those for UI. You can go top down. It's easier to melt. So if I got a UI and I want to change it into the decomposition, I can do that. But going bottom up is actually not that easy from the point of view of going between the layers. Going bottom up design wise is very easy. I take the Swagger document, I create a bunch of unit tests at the API service level, and then I can reuse those for test scenarios. So, and that's the transition between dev and test. Again, hopefully that was useful. We are right coming to the end. I don't know if I get cut off at the hour or not, so I've got time, so I'll just keep going. If we get cut off, you guys know who to email. Okay, a UI test written with data-driven testing approach. Now we are thinking to start BDD for UI. Just want to check if it's a good approach to convert all our UI to BDD. What I would do is I would run them in tandem to start with, to be honest. I'm not a big fan of wasting a whole bunch of time migrating old stuff to new stuff. I do think I do think BDD is a better approach than a keyword-driven approach or a data-driven approach to testing, because you spend a lot of time maintaining the modules. And it's not as powerful. But I would not say just hey, let's spend an entire release migrating everything. No, don't do it that way. Prototype it, pilot it, get the process working properly for you, and then say, okay, let's go ahead and convert them. Don't just convert them all at the beginning. You're going to create yourself a disaster. Identify a few that you want to convert. You don't want to move those over to start validating, and then build new tests moving forward on the BDD platform. Don't go back to the data-driven one. Can the AI testing help with accessibility testing? So the short answer to that question is not today, but please email us, because that is actually an area that we are actually going to be introducing something in the near future. So accessibility testing around ADA, for example, is a key component. Okay, unfortunately, I'm going to have to wrap up now. I have gone over the hour. Thank you very much for everybody staying on. I really appreciate it. Great questions. Super happy. Thank you. Have a great rest of the conference. Thank you for getting up early with me. I hope you enjoyed your coffee. Hope you had some breakfast. I didn't. But yeah, thank you again. Please feel free to reach out to us. Come by the booth, check out the guys there, join the summit. We'd love to see you there on that. So thank you very much. Have a great day.